This is geometry, section 8.2, special right triangles. So there's two types of special right triangles. And basically, if we memorize the patterns for them, it's a shortcut to doing the Pythagorean theorem. So what we learned yesterday, the Pythagorean theorem, can be used for pretty much everything in this section, but this section just teaches us shortcuts for it, so it doesn't take as long. So first we have to review a couple of things. Square root of 2 times square root of 2. If I multiply something by itself, it really means that thing squared. So if I square a square root, the square root just goes away. So the answer to this would be 2. Similarly, the answer to this, square root of 3 times square root of 3, would be 3. Square root of 5 times square root of 5, 5. 7 times the square root of 8 times the square root of 8, well, this part would give me 8, and then it's 7 times that, which is 56. This would be 3 times the square root of 10 times 3 times the square root of 10, so 3 times 3 is 9. Square root of 10 times square root of 10 is 10. 9 times 10 is 90. Another thing, when we have a radical or a square root in the denominator, we don't like it when that happens. We can't have that. It's improper. So to get it out of the denominator, we multiply by that root over itself. The reason we can't just multiply the bottom by that is because it changes this number. But if I multiply by the square root of 5 over the square root of 5, that number is really just 1. So I'm not changing this number at all, because 40 over root 5 times 1 is just itself. So I'm not changing it. It's going to look different, but it's still the same number. So when I do that, 40 times root 5 over, remember, root 5 times root 5 is just 5. And then I can reduce the 40 over 5 to 8. I cannot reduce a number outside a radical with a number inside a radical. So this does not reduce. This stays square root of 5. Similarly, I would have to multiply this one by root 2 over root 2. So it would become 18 root 2 over 2. And then this would reduce to 9. So this would be 9 root 2. Same thing for this one. So this becomes 10 root 2 over 2. And then 10 over 2 reduces to 5. Same thing, 500 root 2 over 2, 500 over 2 is 250. For this one, when I multiply by root 2 over 2, I get 7 root 2 over 2. 7 over 2 does not reduce. We could turn it into 3.5, but generally we don't like to have decimals with radicals, so we're just going to leave this as 7 root 2 over 2. All right, so our first special right triangle. The first special right triangle is called a 45, 45, 90 triangle. So it comes from when I take a square, and we know that a square has all 4 sides congruent, and all 4 angles are right angles. So when I take a square and cut it in half, like it shows over here, I create 2 triangles that still have a 90-degree angle in them. The sides are still each 1, which these are now the legs, because I just created a triangle. And these 2 angles at the corners now become 45 each, because I took this 90 and I cut it in half. So 90 cut in half is 45. So that's why we call this a 45, 45, 90 triangle. So now the trick is figuring out what this new side is, this hypotenuse that I've created, the side across from the right angle. To do that, we can use the Pythagorean theorem, which we learned yesterday. So 1 squared plus 1 squared equals c squared. 1 squared is 1, so 1 plus 1 is 2, equals c squared, and then we need to take the square root of that. Square root of 2 does not come out evenly, so we leave it as the square root of 2. So every 45, 45, 90 triangle is going to follow this pattern. It's going to be similar to this one. Okay, so since it's a 45, 45, 90 triangle, since these 2 angles are the same, these 2 angles, that also means that these 2 sides are the same. So really it's an isosceles triangle with a right angle in it. So if these 2 sides are the same, we're just going to call those x. We're going to figure out a formula for every 45, 45, 90 triangle. So if these 2 sides are x, the hypotenuse is always going to be whatever that number is, x, times the square root of 2. So if I have this triangle down here, if this piece is 8, this piece with the other tick mark on it is also 8. So n is 8, and p is now just 8 root 2. I just take whatever this is, whatever these legs are, multiply it by root 2 to get the hypotenuse. Going backwards, if I have the hypotenuse, I would just take away or divide by the root 2. So then it's going to go away, and each of these pieces is 13. Same thing as the first one. If this is 3, t is also 3, and then the hypotenuse is 3 root 2. Okay, if I already have a root 2 in the leg, or if the hypotenuse doesn't have a root 2, what happens? So I just said on the last page, if we have these two pieces, we multiply by root 2 to get the hypotenuse. Well, that's still going to apply. So we take 3 root 2 times root 2. But we know from what we did at the beginning of this page that root 2 times root 2 is just 2. So this becomes 3 times 2, which is 6. So v is 6. And w is just the same thing as this, so w is also just 3 root 2. This one. So going backwards, if I had this 6 and I needed to find this, like we said on the last page, I would now divide by root 2 to get that. So we're going to do that here. 16 divided by root 2 is going to give us g and e. So 16 divided by root 2, we have to get rid of the root on the bottom. So we multiply by root 2 over root 2. That gives us 16 root 2 over 2. 16 over 2 reduces to 8. So each of these pieces is 8 root 2. If we took 8 root 2 and did what we did over here with the 3 root 2, whoops, we use this one. So 8 root 2 times root 2. Root 2 times root 2 is 2. Times 8 is 16, which we know is the hypotenuse. Okay, so that's the 45, 45, 90 triangle. Now for the other type of special right triangle. This one is called a 30, 60, 90 triangle. So where this one comes from is an equilateral triangle. Equilateral meaning all the sides are the same and all the angles are the same. So if I have a triangle and I know the 3 angles add up to 180 degrees, if I take 180 and divide by 3 evenly, I get 60 degrees. So each of these angles is 60 degrees. So now if I take that and I slice it in half, right down the middle, I get this. This angle is still 60. This angle now becomes a right angle because I cut this straight line right down the middle. So this is now 90. This angle was the 60 degrees, but now I cut it in half. So it's now 30, hence the 30, 60, 90 triangle. So this piece was not touched. This stays 2. This piece was this piece cut in half. So now this piece is 1. The dotted line, the other leg of this triangle, we can find using the Pythagorean theorem. So now this would be called B, or A. So 1 squared plus B squared equals 2 squared. 1 squared is 1, 2 squared is 4. Subtract the 1. Square root. B is the square root of 3. So just like the 45, 45, 90, every 30, 60, 90 is going to be similar to this one. Okay, so the shortest side, the shortest leg, is going to be across from the 30-degree angle. This leg across from the 30 is always going to be shorter than the one across from the 60 because 30 is a smaller angle than 60. So we're going to start with that one. We're going to call that one x. If I think about this as my x, so this is 1. The hypotenuse is always going to be double whatever this shortest leg is because that came from this piece being cut in half. So to get from this chunk to this, I'm just going to double it. So the hypotenuse is going to be 2 times whatever x is. And the longer leg is going to be whatever x is times root 3. Just like for the 45, 45, 90, the hypotenuse is whatever the leg is times root 2. Now for the 30, 60, 90, I take the shorter leg and I multiply by root 3 to get the longer leg. That's always going to happen. It's always going to follow this pattern. So if I start with the longer leg, so 4 root 3, then the x would just be 4. I would just take away the root 3. So k would be 4 here, and then to get the hypotenuse, I just double it, 8. For this piece, or this triangle, I have the shorter leg, so that's my x. So I multiply it by root 3 to get the other leg. So the m would be 8 root 3, and then I double it to get the hypotenuse. So n would be 16. For this one, we have 7 root 3 right here, which is across from the 60, so that's the longer leg. So the shorter leg, I just take away the root 3, so p would be 7. Then I take the shorter leg and double it to get the hypotenuse, so r would be 14. For this last one, D, we have the hypotenuse, so we know to find the shorter leg, it comes from the equilateral triangle. So if this whole thing was 22 from an equilateral triangle, then U would just be 22 cut in half. So U would be 11. And then to get the longer leg, I just take 11 and multiply by root 3.